Hey, it's Mr. Lum, and we're going to be starting Unit 4 today. Sorry I can't be there. And it's going to be about acid and base chemistry. And we have a lot of definitions to kind of get through, so I provided you with some guided notes so that you can kind of write down little things on the side of it and maybe fill in a few of the blanks as we go along. So, anyways, we're going to be talking about acid and base chemistry. And before we do that, we're going to talk a little bit about the definition that you have been told on what an acid and a base is. So in grades 9, 10, and 11, you've been told the Arrhenius theory of acids and base. This theory says that an acid is a substance that makes hydrogen ions or H plus ions, and a base is a substance that makes OH minus ions. And a salt is just a product of an acid and base reaction or an ionic compound. So the Arrhenius theory kind of says that these things contain hydrogen ions. So an acid would be, so examples of acids would be HCl, H2SO4, HNO3. These are all acids. They not only contain hydrogens, but these hydrogens are also able to dissociate when placed in water to make H plus, and that H plus part is the acid part, and then it makes some Cl minus. This one's a little bit weird. It can make, technically has the ability to make two H pluses, and sometimes it just makes one, and we'll talk about that later. So it can make that H plus there. And this one can make an H plus and an NO3 minus. So since they're all making that H plus, that means they're all acids. Okay. Now, what a base is a base is something that makes OH minus. It also is something that contains OH minus. So under this definition of what an acid and base is. So another example of a base would be something like NaOH, so sodium hydroxide, KOH, calcium hydroxide. And these all contain that OH there, which makes them a base, and they all produce Na plus and OH minus when you throw them in water. Oops, that doesn't produce Na. It produces K plus and OH minus when you throw it in water. And this will make Ca2 plus and two OH minuses when you throw it in water. Okay, and this is the part that makes it the base. Okay, and we'll talk about this one a little bit later, but sometimes that can be making H2SO4 can make two hydrogen pluses plus an SO4 2 minus. But we'll talk about when it does that and how it does that, and it's a little bit weird. So some of them can make those double acids sometimes, but we'll talk about that later. Now, again, this is your grade 9, 10, and 11 definition of acids and bases, and we are going to use another definition in a little bit. But the neutralization kind of just says, like, you get an acid plus a base, and it typically makes salt and water, like that. And you don't always have to have this. You could have KOH, or sorry, I was going to go KOH, but we'll put our acids first. We'll put HCN, and we'll put KOH. H2O, right, like that. So the first one, we have hydrochloric acid plus sodium hydroxide makes salt in water. And in the next one, we have hydrocyanic acid plus potassium hydroxide makes KCN, which is potassium cyanide, and water as well. And even though it's potassium cyanide, it's not the typical type of salt that you're used to. We would still call it a salt because it's an ionic compound. It is the product of an acid and base. These are the definitions that you're used to from grade 9, 10, and 11. And so we are going to be changing this definition, and it's going to be a little bit more inclusive. But I want to emphasize that in water, acids typically make those hydrogen pluses. They also contain those hydrogen pluses. That's what acids are. And under the old definition, bases contain those OH minuses, and they also produce OH minus when you throw them in water as well. And that's that old definition, and we are going to be changing that. Now, just some properties of acids and bases. They are both electrolytes. And if we remember what electrolytes are from our chapter 3 or unit 3, is that electrolytes conduct electricity when they're placed in water. In other words, they make ions in water. Acids typically make H plus in water, and bases typically make OH minus in water, and sometimes acids will produce other types of electrolytes as well. So for example, if you threw HCl in water, it is producing H plus, and it's also producing Cl minus. Those are both ions, and so they'll both conduct electricity. And for bases, say if you threw NaOH in water, it'll produce OH, and it'll also produce some Na plus, and those will conduct electricity. Now, another property of acids is that they react with metals to make hydrogen gas. They are sour tasting, so things that taste sour are typically acidic, and they turn litmus paper red in color. And we'll talk about, later on, we'll talk about more about all the different acid-base indicators. Bases, on the other hand, they feel slippery and like soaps, and they taste bitter. That's why we don't typically use basic things for cooking, and they typically turn litmus paper blue. And so the way I like to remember that is they turn litmus paper blue, and if it's blue, it's a base, and if it is red, it's an acid. Now, I said that acids produce H plus. So for example, say if we had some HCl and we threw it into water, what's going to happen is that it's going to be making H plus and some Cl minus. Now, when we go on and we talk more about acids and bases, we're going to talk a lot about this thing right here, this hydrogen ion. Now, this hydrogen ion, it comes from the dissociation of like HCl or whatever acid that we're working with. So if we're working with, say, nitric acid, HNO3, it'd be the same thing. It would turn into H plus and NO3 minus. And this H plus right here, this hydrogen ion, we will often call it a proton. So we'll say, there's the proton then binds with water, or we'll talk about that proton often, because normally hydrogen looks like this. If I were to draw a Bohr diagram of hydrogen, hydrogen has one proton and one electron. So it would look kind of like like this, right here. Or in other words, hydrogen would have 1 proton. Okay, so this is a proton, right, like that. And then it would have 1 electron, something like that. That's what hydrogen is. Then, if it's a hydrogen ion, so this is an atom, if it's a hydrogen ion, in other words, this is H, and this is H plus. That plus, this plus right here means it lost an electron. So if it loses an electron, it's just a proton. So what is a hydrogen? What's the difference between a hydrogen ion and a proton? A hydrogen ion is the same as a proton. Okay, so you'll see those words kind of like interchanged quite a bit. We'll say, the hydrogen ion is doing this, it's reacting with this, or the concentration of hydrogen ions is this. And we'll also talk about, or we could say the proton is reacting with this, the concentration of protons or hydrogen ions is this. Okay, so hydrogen ion is a proton. Now, what does this proton do when it's thrown into water? Well, or this hydrogen ion, what does it do when it's thrown into water? So what we didn't draw in here, right here, is we didn't draw water. And water actually reacts with acid. So if you take like hydrochloric acid, HCl, and you take a very concentrated HCl and throw it into water, and you had a thermometer in there, what you would notice is that thermometer would immediately start going up because the water is actually reacting with the hydrochloric acid. And this is what the reaction does, is that HCl dissociates with that and turns into the H plus and the Cl minus. Now, what happens is that this H plus will react with water and turn into H3O plus. So we have like this proton with this water right here. Now, this water is what we call a polar molecule, and this side right here is relatively positively charged, and this side right here is relatively negative charged. And what happens is that this positive proton or hydrogen ion will come in and it will attach to the water, to the oxygen, and it makes this H3O plus. This H3O plus right here, this thing right here is called hydronium. Okay, and hydronium is an ion, so that's why we call it hydronium ion. It's H3O plus. And what I want to emphasize is that the hydronium ion, the hydrogen ion, and the proton, those are all pretty much the same thing. Because we can call this thing right here, this H plus, we can call it a hydrogen ion, we can call it a proton, but when that's in water, all of those hydrogen ions are going to react with water, and it's going to form H3O plus. So you can call it a hydrogen ion, you call it a proton, but hydrogen ion or proton, they're all going to react with water and make hydronium ions, which is H3O plus. So you'll almost see those three words mixed up interchangeably all the time. Sometimes I'll call it a proton, hydrogen ion, hydronium ion. You can see any one of those kind of terms, all representing the same thing. All represents that active component of what an acid is. So remember, an acid just makes those protons, in other words, those hydrogen ions, which react with water and forms those hydronium ions. And that's going to bring us to the definition that we're going to be using in Chem 12, and that's the Bronsted-Lowry theory of acids and bases. It's just kind of like a different way of looking at what an acid is and what a base is. So the Arrhenius theory says that acids produce H plus and bases produce OH minus. And Bronsted-Lowry kind of changes it and says that acids donate a proton to other substances and bases accept a proton from other substances. I want to emphasize that the word proton here, proton means H plus, right? Because we can say that hydrogen ion is the same as a proton. So this kind of opens up the definition of what an acid is and what a base is. It says that it says that the same things that are for the Arrhenius definition of an acid is an acid. So HCl is still an acid under Bronsted-Lowry definition. Why is it still an acid? Well, because you can see that it'll give up that hydrogen ion right there. Or in other words, say if I drew it a little bit differently and I wrote HCl plus water turns into H3O plus, okay? And then plus Cl minus. So here was our acid. It started off at HCl. It donated an H plus, and since when you're donating it, it loses an H plus, and it turns into this Cl minus right here. So why? So HCl is still an acid under this definition because it is a donator of hydrogen ions, or in other words, it's a donator of protons. And so same thing with like HNO3, and say we had it with water again. And as you can see, it starts off at HNO3, it donates, and that means it loses a hydrogen and becomes NO3. And so that means that this is still an acid. So the acids are the same from the Bronsted-Lowry definition of acids but the Bronsted-Lowry definition changes what a base is. Before it used to be it has to have OH minus in it. Now what we're saying is that a base is anything that accepts a proton. And that really opens up the definition of what a base is. So you may have heard of like baking soda is basic. Well, baking soda does not contain hydroxide. Baking soda contains like carbonates in it. And same with like washing soda and all that. They don't contain hydroxide, they contain carbonates. So here's an example of like baking soda, NaCO3, well, Na2CO3, something like that. Now the Na is just a spectator, and we'll talk a little bit about that later. So this is CO3 2 minus. And say if we took that baking soda and we threw it in water. We took that carbonate and we threw it in water. So here's our water right here. Now, what's going to happen is that this is our base right here, and it wants to accept a proton. Now, where can it get a proton? It gets the proton from things like water right here. So it grabs that proton. It just grabs one of them. And so it turns into HCO3. Now it gained one of these protons, and so it was 2 minus, and now it's just a singular minus, like 1 minus. Okay? So what did it do here? It didn't donate a proton, it accepted a proton. And since it accepted a proton, that is why it's called a base. Now, what is H2O left with? Well, before it was H2O, but it lost one of its hydrogens, and so now it's left with just one H and one O, or in other words, we can just write OH minus, like that. Now, here's the weird thing about H2O. What did H2O do here? It donated a proton, didn't it? Do you see it? From H2O, it had 2 protons. Now it has only 1 proton. So it donated a proton. So by under that definition, or the Bronsted-Lowry definition, H2O in this case right here happens to be an acid. Now if we go back, we'll look at H2O over here. H2O right here accepted a proton to turn into H3O. So it gained a proton. So under this definition, H2O in this case is a base. And this one right here, under the Bronsted-Lowry definition, H2O right here would be considered a base. So in some circumstances, H2O can be an acid. In other circumstances, H2O can be a base. And so the Bronsted-Lowry definition of acids and bases is that it's a lot more inclusive of what a base can be. So anything that can accept a proton is anything that can accept a proton is a base. And it's a little bit more inclusive of what an acid can be. Anything that can donate a proton is an acid. And so now we can consider water, in certain circumstances only, water can act like an acid. Now, this is going to bring us to the next thing right here, is that there's different types of acids. And what it means is that we have what's called a monoprotic acid. Now, mono meaning one, protic meaning proton, and acid meaning acid. That means one proton acid. Di means 2 proton acid, 2 proton acid, 3 proton acid. Poly means many proton acid. Okay, so what does this monoprotic acid mean? It means it can only give 1 proton. It can only give, diprotic is 2 protons, 3 protons, and then many, many protons. So we're just going to talk a little bit about, I have 5 acids up here, and we're going to see what type of acids are these things. So for this one right here, it has the ability to change into, it can go like this, 3 hydrogens plus a PO4 3 minus. That means since it has the ability to donate up to 3 protons, that means this is a triprotic acid. Okay. Now, it doesn't necessarily mean that it will. We still call it a triprotic acid. It's still possible that it could, and we'll talk about this later. It might only donate 2 protons, right? It has 3 to donate, but it might just only give up 2 of those protons. And if that's the case, then it becomes HPO4 2 minus like that. Okay, so it holds on to one of these things. And it might only just donate 1 proton too. Oops, just 1 minus. Okay, but we still call it a triprotic acid. Okay, so what about this next one right here? This one can only donate 1 proton, so we call it a monoprotic. This one right here, someone yell it out. Hopefully you're right, monoprotic. Okay, this one right here, diprotic. Now you can technically call this diprotic, or you can call it polyprotic, because it does more than one. And same with this, you could call it polyprotic. But it's nice to be a little bit more accurate and say how many protons can it give up. And here's 4, we'd probably just call it just polyprotic. It means it can donate many different protons. Now I wanted to give another example of an acid. And this one's a little bit harder, and you'll see a few examples of this, but we'll talk about it. So there's a few of them right here. So it's mainly all the organic acids. So the most famous organic acid, or the one that maybe you're used to, is acetic acid, sometimes called ethanoic acid, CH3COOH. Now, you might be thinking that this one's a polyprotic acid, but this is actually a monoprotic acid. The only hydrogen that's available for being an acid is this one right here. If you talked about carboxylic acids in Chem 11 or in organic chemistry, you would know that this H right there is the only proton that is available for donation. These ones are not available for donating. Okay, so this is what we call a monoprotic acid still, because only it can become acetate, which is CH3COO minus, and that one H plus. That's, again, this is the only hydrogen that is available for like that. I will give you a list of all the different types of acids that we're going to be dealing with, but acetic acid is a monoprotic acid. There's a couple of other monoprotic acids that are out there, but we can highlight them when I give you a data sheet. But like there's phenol in there, and that is C6H5OH. And again, it's only this H at the end right there. There's all the carboxylic acids like methanoic acid, which is this is called ethanoic acid or acetic acid because it contains 2 carbons. But there's also like methanoic acid, which means that it only contains 1 carbon. but again, it's only this acid, that H right there, that is available. All the organics have their acid component at the end. But again, we can like highlight all the different ones that are there. But yeah. Okay. Now, also under the Bronsted-Lowry definition, it then means that if the ability to donate a proton makes something an acid, and the ability to accept a proton makes something a base, what happens if something can donate a proton and accept a proton? Well, if it can donate a proton and accept a proton, then we call it amphiprotic, kind of like ambidextrous, or it's not really the proper root of the word, but or like amphibian is proper. Amphibian means like an animal that can live on land and in water, right? And so amphiprotic means that it has the ability to donate and the ability to accept. So what are things that can donate and accept? As we talked about earlier, water has the ability to donate and it has the ability to accept, and so therefore water is amphiprotic. Now, how can you tell if something else is amphiprotic? There's a couple of exceptions out there, but pretty much anything that is a substance with a negative charge and a hydrogen that has the ability to be removed. So I'll give you an example in a second of there's a hydrogen there, but it doesn't have the ability to be removed. So we're going to kind of fill in these blanks right here and figure out which one is amphiprotic. So here, this one is going to form HSO3 minus plus H3O plus like that. Okay. Now, this one right here, this H2SO3, turned into HSO3 minus right there. So since it donated, it gave up one of its protons. That made it an acid. And this H2O, it turned into H3O. It accepted a proton. That makes it a base. Okay, so let's take a look at some of these other ones right here. We have HSO3 and water. It can do a couple of different things. Let's imagine that this HSO3 minus is an acid. Okay, and that means this one's going to be a base. So if this one's an acid, that means it's going to donate, or in other words, it's going to lose one of its H's. So that means it becomes SO3 2 minus. And this one is going to become H3O plus. Now, if we take the exact same equation, like this reaction is the exact same as this reaction, but we're going to say that this is going to be a base. And that means this one's going to act as an acid. So if HSO3 minus is a base, that means it accepts a proton and becomes H2SO3. If water right here is going to act as an acid, that means it's going to donate a proton. It's going to lose a proton, and so it would become OH minus. So HSO3 is amphiprotic. Okay, it has the ability to act as an acid. It has the ability to act as a base, and so therefore it's amphiprotic. Water is also amphiprotic. It has the ability to act as an acid, has the ability to act as a base. It's amphiprotic. Now you're probably wondering, like, okay, then fine, what is HSO3? Is it an acid or is it a base? If we want to know if you stuck in, like, if you took HSO3 and threw it into water, is it going to act as an acid or is it going to act as a base? And that'll come a little bit later. It'll be a little bit of a calculation to figure out what it's going to act like. But if HSO3 minus is put into a situation where it needs to act like an acid, it'll act like an acid. If HSO3 minus is put into a situation where it needs to act like a base, it'll act like a base. And we can do some calculations to figure out when it'll act like an acid and when it'll act like a base, but that'll come a little bit later. But yeah, anyways, those are the definitions, and hopefully you got something out of that.